Welcome back to the Bleeding Agent channel. If you're listening to this, I'm willing to bet you're currently suffering from what I call integration fatigue.
Oh, yeah. The endless Python glue code.
Right. You're just tired of writing it. You're tired of brittle APIs, the custom wrappers and the just the massive maintenance overhead required to get an LLM to actually talk to your production data.
It's the unglamorous reality of the AI stack right now.
Mhm.
I mean, everyone talks about model weights,
Okay.
right, or context window sizes, but the engineers are just drowning in the plumbing.
Exactly. So today we are stripping away the marketing fluff. We're not looking at demos. We are doing a deep dive into the architecture of the Model Context Protocol, or MCP.
Right.
Now, I have to be honest here. When I first saw new standard in the RSS feeds, my eyes rolled back in my head. We all know the XKCD comic, right? You have 14 competing standards, you build one to unify them, and now you have 15 competing standards.
Yeah, I get that.
Like, why is this not just another abstraction layer that we just don't need in our stack?
That is a completely fair skepticism. And usually I'd be right there with you. But this feels different because it attacks a very specific bottleneck. It addresses the N/M integration problem head-on.
Okay, let's unpack that immediately for the listeners. What is the N/M problem in this specific architecture?
So think about your landscape.
Yeah.
On one side, you have n number of rapidly evolving models. Claude, GPT-4, Llama, whatever drops next Tuesday.
Right.
On the other side, you have m number of data sources. Postgres, Slack, GitHub, local file systems, Sentry. Right now, to get Model A to talk to database B, you are writing a custom adapter.
And then, Model A bumps its API version, or you decide to swap to Model C because it's cheaper, and suddenly that adapter is just dead code. You're rewriting the glue.
Exactly. It is entirely unscalable technical debt. You're building linear connections in an exponential space. If you have 5 models you want to test and 10 tools you need access to, that is 50 unique integrations.
50 repos to maintain. Sounds awful.
It is. So MCP proposes a universal open standard protocol. The shorthand everyone is using is that it's a USB-C port for AI applications.
Which is a great soundbite. But let's actually get technical. The mission for this deep dive is to dissect the topology, the transport layers, and the JSON-RPC message flow that makes this function.
Let's do it.
Starting with topology. The spec uses very specific naming conventions: hosts, clients, servers. And I think this might trip you up if you're coming from traditional web dev because they don't mean what you think they mean.
It is distinct. Let's start with the host. In MCP, the host is the AI application itself. This is the container. Think of the Claude desktop app or an IDE like Zed or VS Code.
Okay, so the host is the runtime environment where the user is actually typing prompts, the front end for the intelligence.
Correct. Now, inside that host, you have the client. This is the protocol level component. Its sole job is to maintain a one-to-one connection with a server.
A one-to-one connection.
Yes. And the server is where the actual work happens. The server is an independent process that exposes the data or the tools.
That independence is the core architectural decision here, isn't it? The server isn't some Python library you pip install into the model's environment. It's an entirely separate process.
Precisely. It can be a local process running on your machine, spawned by the client, or it can be a remote service running over HTTP. The engineering principle here is strict isolation.
The model doesn't need to know how the Postgres database works.
Right. It just needs to know how to talk to the MCP server that sits in front of the database.
So if you're an engineer building internal tools, the value proposition is that you stop building a Claude to Jira integration. You just build a Jira MCP server.
And once you build that server, any MCP-compliant client, whether that's Claude or a CLI agent or a brand new IDE, can consume that server immediately. You write it once, you deploy it to any agent.
That's the interoperability play. But there's also a massive efficiency gain regarding context windows, because the current way most teams handle this is basically brute force our RAG. You just dump the documentation into the prompt and hope for the best.
Or you dump your entire database schema into the context window and pray the model figures out the foreign keys. It's incredibly inefficient, it burns tokens, and it distracts the model with noise.
Yeah. So MCP allows the model to basically reach out dynamically. It queries only what is needed via tools and resources.
It turns the model from a library researcher who has to memorize every book in the building into a researcher who just knows how to use the card catalog to fetch one specific book on demand.
I like that analogy. And because it's fetching on demand, you get a much better security boundary, which is the part that usually worries me with these agentic setups.
Oh, absolutely.
If I'm running a local agent, I really don't want it sending my entire local file system structure up to some cloud endpoint. How does MCP handle that boundary between local data and the model provider?
This is critical. In the local architecture, the server is usually spawned as a subprocess. The host process dictates the lifecycle. And crucially, the server does not see the whole conversation history.
Wait, really? It's completely stateless regarding the user's chat.
Effectively, yes. The server isn't listening to your chat with the LLM. It only receives the specific tool inputs or the prompt parameters that the host decides to send it.
So if I ask my agent to, analyze a bug in auth.py, the file system server only sees the request read auth.py. It doesn't see the previous 10 messages where I was venting about my coworker's spaghetti code.
It sees nothing but the request for that specific file. That privacy barrier is built directly into the protocol flow. The host acts as a strict gatekeeper.
Okay, that is very reassuring. Let's get into the wire protocol itself. Looking at the specs, I see JSON-RPC 2.0, which feels almost retro. We're talking about bleeding-edge agentic workflows, and we're using a protocol from the mid-2000s.
It's old and reliable, but it fits the use case perfectly. JSON-RPC is agnostic to the transport layer. It's a stateful session protocol with a very clear structure: requests, responses, and notifications.
You don't need the overhead of REST for this kind of remote procedure call.
Exactly.
Yeah.
But the really interesting part is the transport layer itself. MCP defines two primary transport mechanisms, and they behave quite differently depending on your deployment.
Let's start with Stdio, because that's what most developers are going to see when they configure their local IDEs or mess with the Claude desktop config file.
Right. Stdio is for local agents. The client, your IDE, spawns the server as a subprocess. Communication happens directly over standard input and output.
So it's just piping data directly between processes, std in and std out.
Yes. It's extremely fast, it's synchronous, and it is secure by default because there is literally no network exposure. It utilizes the operating system's native process isolation.
The server runs as you with your system permissions, but contained within that pipe.
Right. But obviously that doesn't scale if you need to connect to a centralized service. You can't use Stdio for that.
Yeah, you aren't going to spawn a local subprocess for a shared production database or a Salesforce instance. That's where the streamable HTTP transport comes in. But looking at the spec, it isn't just a standard REST API call, it's a hybrid.
It's quite sophisticated. It uses server-sent events, or SSE, for the downlink, that's server-to-client messages, but it uses standard HTTP POST requests for the uplink, client to server.
Why the split? Why not just use WebSockets and be done with it?
You could, but SSE plus POC is vastly friendlier to existing corporate network infrastructure. It allows for asynchronous communication and streaming responses, which you absolutely need for LLMs, without the persistent connection overhead or the firewall headaches of full web sockets.
It's easier to inspect, easier to proxy.
Exactly, but introducing HTTP introduces web security risks. The spec is very explicit about validating the origin header.
You have to. If you don't validate origin, you are wide open to DNS rebinding attacks. You really don't want a malicious website opening in your browser to start acting as a client to your local MCP server.
The protocol enforces a very strict handshake to prevent exactly that.
Okay, so we have the pipes, stdio or HTTP. Let's talk about that handshake. I fire up my client, it connects to a server. What is the very first thing that happens on the wire?
This is the initialization phase of the lifecycle. It starts with an initialized request from the client. It sends its protocol version, and most importantly, it sends its capabilities.
Capabilities. I keep seeing this word everywhere in the documentation. It seems like the core differentiator from a basic API.
It really is.
Yeah.
The server then responds with its capabilities, and they have to agree. Does the client support sampling? Does the server support notifications? Can the server handle experimental features?
So they don't just assume endpoints exist, they explicitly declare features. That prevents that awkward API version mismatch where a client tries to call a deprecated function and just crashes the whole pipeline.
Correct. And once they agree on those capabilities, the client sends a final notification initialized message that locks the session. Only then do they actually start exchanging work.
Let's talk about that work. The MCP spec defines three main primitives, the API surface, essentially. Resources, tools, and prompts. Let's break them down, starting with resources. This feels like the read-only layer.
It is. Resources are for passive data reading. They're defined by URIs. Think file.logser.txt. The key here is that it supports resources list and resources read. It's how the model reads the world state.
But it isn't just static reading. I saw a section on subscriptions.
Yes. And this is huge for monitoring agents. A client can subscribe to a resource. So if that error log file changes on the disk, the server actively pushes a notification to the client in real time.
So the LLM gets the new data without having to constantly pull the file.
Exactly.
That's powerful. You could have an agent watching a log stream, and it only wakes up when it sees a specific trace pattern. Okay, next up are tools. This is the action layer.
Tools are the actuator of the agent. They are executable functions defined by a JSON schema. The LLM decides it needs to call the tool. The host reads that request to the server executes the actual code, runs a SQL query, hits an API, restarts a pod, and returns the result.
This sounds exactly like function calling in the OpenAI API. Is it just a wrapper around that concept?
Conceptually, yes, but structurally it's very different because the tool definition lives entirely on the server, not hard-coded in the host's application logic. It decouples the tool from the model completely.
Oh, I see.
If you update the tool schema on the server, the model sees the new schema instantly on the next connection. You don't have to redeploy the agent.
That is the N by M solution in practice right there. And finally, prompts. This one actually confused me initially. Why does the server need to define prompts? Isn't prompting the user's job?
Think of it as prompt engineering as code. It allows a server to define prepackaged workflows or templates. A GitHub MCP server might expose a prompt called Analyze This Bug Report. It allows the domain expert, the engineer writing the server, to guide how the LLM interacts with the data.
Ah, so the server developer is basically saying, I know the schema of my database best, so here's the mathematically optimal way to ask me for data.
Exactly. It reduces the prompt engineering burden on the end user. You package the query expertise alongside the data.
Now, I want to pivot to a feature that sounds like a total inversion of control. Sampling. This is buried under the Advanced tab in the docs.
Sampling is fascinating architecture. Usually the client asks the server for things, but with sampling, the server can actually ask the client, which is connected to the LLM, to generate a completion.
Wait, so the database server can ask the LLM a question?
In a way, yes. Imagine an agentic loop where the tool retrieves some messy, unstructured data, say 1,000 lines of raw JSON logs. Instead of sending all that bloat back to the user or filling up the main context window, the server can request the LLM to process or summarize that intermediate data before returning the final tool result.
So it enables agentic behavior within the tool execution itself. It blurs the line between a dumb tool and an intelligent agent.
Precisely. It keeps the heavy lifting opaque to the user. The tool just returns the synthesized answer, but internally it might elude through the LLM 3 times to get there.
And if you want to get even more complex, there are MCP apps. This is an extension that allows servers to return interactive UI components.
Like actual widgets, HTML and JavaScript, rendered in a sandboxed iframe by the host. So a color picker tool doesn't just return a hex code string. It can actually pop up a UI widget in your chat window.
That is wild. Moving from text-based interfaces to full GUI applications generated on the fly. But let's pump the brakes and talk security again. We mentioned the confused deputy problem earlier. For the security-minded engineers listening, what is the specific attack vector we're looking at here?
This is a classic privilege escalation scenario. Imagine a malicious client connecting to a proxy server that talks to a third-party API. If the proxy blindly forwards credentials or doesn't validate redirect URIs strictly, the malicious client can trick the proxy into performing actions on behalf of the user that the user never authorized.
The proxy becomes the confused deputy. It thinks it's doing its job, but it's being manipulated to exfiltrate data or modify state.
Right. And then you also have to worry about SSRF, server-side request forgery.
Always a headache.
Always. If a malicious server redirects a client to localhost, it could try to scan the user's internal network or hit AWS cloud metadata endpoints.
So if you are building an MCP client or server, you need to operate on zero trust.
Absolute zero trust. You're executing code and fetching data based on instructions from external, non-deterministic entities. The protocol gives you the tools to be secure, like capability negotiation and strict origin checks, but you still have to implement them correctly.
Let's zoom out to the adoption landscape. Who is actually using this in production? We know Anthropic created it and open sourced it. Is this just an Anthropic ecosystem play?
It started there, but the momentum has shifted significantly. Block, the company behind Square, is a major player now. They contributed Goose, their open source agent framework, to the ecosystem.
And I see tool support is already live in Zed, Replit, SourceGraphs, Kodi, JetBrains, IDEs.
That's the right one's benefit in action. A server built for Claude Desktop works in Z without a single line of modification. It works in Goose without modification.
But the big news regarding governance is the Linux Foundation, right?
Yes, they just formed the Agentic AI Foundation, the AAIF, and the founding members include Anthropic, Block, and crucially, OpenAI.
OpenAI is involved. That seems significant because historically they usually prefer to build their own moats.
It's extremely significant. They contributed their agents.md specification alongside MCP. This signals to the industry that this isn't a vendor lock-in play. It's a genuine push for a neutral industry standard.
If OpenAI and Anthropic are sitting at the same table under the Linux Foundation, this protocol has serious legs. It creates a safe space for enterprise adoption. You aren't betting your architecture on one startup's proprietary API.
Exactly. You're betting on a standard that the biggest players are standardizing on.
And the ecosystem is growing fast. We already have pre-built servers for Postgres, Google Drive, Slack, Git, Sentry.
It's rapidly filling in the gaps. The open source community is building servers faster than the core platforms could ever build native integrations.
So look into your crystal ball for us. 5 years from now, where does this technology go?
I think we see the end of custom connectors entirely. MCP compliance will become a standard requirement for SaaS APIs. Just like you expect a B2B product to have a REST API today, in 5 years, you will expect them to provide an MCP server endpoint.
So Salesforce or Jira will just ship an MCP endpoint out of the box. Just here's our MCP URL, plug it into your agent stack.
Exactly. Connect your agent here. And that shifts the architecture for interoperability. We will see agents moving fluidly between environments. You start a task in your local IDE, and then you push that agent state to a cloud dashboard to finish a long-running job. The agent carries its toolset, its MCP connections with it.
It sounds like Kubernetes for agents. A mesh of MCP servers orchestrating complex workflows across distributed system.
A distributed mesh of intelligence.
Oh.
But the battle is going to be between the closed-wall proprietary agent stacks and this open MCP ecosystem.
The classic protocols versus platforms war.
It is. And protocols usually win in the long run because they scale better than any single company's engineering org can. No single company can build every integration for every possible data source on Earth. An open protocol allows the world to build them.
So for the senior engineer listening to this deep dive right now, what is the immediate action item for their team?
Stop writing glue code.
Easier said than done, but point taken.
Seriously, though, if you are building internal tools right now, stop building custom API wrappers for your LLMs. Build an MCP server instead. But the one thing I want listeners to really take away, the thing that makes its architecture robust, is capability negotiation.
Why that specific feature?
Because it is what makes the system future-proof. The ability for a client and server to dynamically discover and agree on what they can do, logging, sampling, tool execution, without hard-coded assumptions. That is the killer feature. It allows the protocol to evolve without breaking everything that came before it. It means we aren't going to be rewriting this entire stack in 6 months.
It decouples the innovation on the model side from the innovation on the data side.
Exactly.
Well, you heard it here first. Stop writing glue code. Start building servers. That is it for this deep dive into the Model Context Protocol. Think about how capability negotiation might change how you design your next internal tool. Check the show notes for links to the specs and the repositories, and we will see you next time.
Keep building.